My dear students, today I am going to discuss about Kirchoff's voltage law. In the last video, I discussed about Kirchoff's current law. Now, first I will tell you the statement. Kirchoff's voltage law states that in any closed mesh, the algebraic sum of the EMFs plus the algebraic sum of IR drops is equal to 0. Why we are using the algebraic sum term? Because the EMF value, it may be positive or negative. Similarly, the IR drop also, it is algebraic sum. So whenever we are using the term algebraic, means it may be positive or negative. In any closed mesh, the sum of EMFs plus sum of IR drops is equal to 0. So it can be explained as follows. Let us consider a closed mesh. Now I am selecting a closed mesh. It may be called mesh or loop. So I am selecting a closed mesh consisting of batteries and resistances. Now, for example, I am selecting the closed loop like this. You can select any loop, doesn't matter. So I am selecting the loop like this. Okay. Now I will put the names as A, B, C, D. What is a closed loop? The closed loop is nothing but if you start with one node, it must end with that node. For example, the closed loop, like if I am starting with node A, B, C, D, A is a closed loop. Suppose if you start with B, then what is a closed loop? If you start with B, B, C, D, A, B. Are you following? B, C, D, A, B, and so on. But I am selecting the loop, this loop, A, B, C, D, A. What this loop consisting? It consisting of different EMFs like E1, E2, E3, E4, and different resistances like R1, R2, R3, and R4. But whenever we are telling about the drop, resistance means if R1 is a resistance, when we say that there is a drop when there is a flow of current. Suppose if I1 is flowing through R1, then the drop is I1 R1. Similarly, if I2 is flowing through a resistance, I2 is flowing through a resistance R2, then the drop is I2 R2, and so on. Is it clear? Now, what is our law? This is a closed mesh. In any closed mesh, the algebraic sum of EMFs and the algebraic sum of IR drops. Why we are calling IR drops? Here there is a current I1. I have taken the current I2 here, I3 here, and I4 here. Okay, you can choose as you like, but I have chosen like this. Now this is minus to plus, plus to minus, minus plus, and plus minus. Now, just like Kirchoff's current law, while applying the Kirchoff's voltage law, we must follow some notation. So what is the notation? Notation or convention? We must follow some rules. So before applying the KVL to this closed loop, we are following the rules. There are 4 rules. 2 rules. For the first rule is, in case of battery, if the direction is like this, minus to plus, and if the battery voltage is E, and if you follow the direction in this direction, that means minus to plus. This is in short form, we will call it as DOT, that is direction of travel. Suppose I am traveling from node A to B, B to C, C to D, and so on. In which direction I am following? Clockwise direction. This is your DOT, direction of travel, right? So suppose if I am traveling from A to B, there is a battery. I am encountering a battery. So in that battery, we are flowing in which direction? Following minus to plus. In such a case, this value of EMF is taken as positive E. So you can remember easily that we are traveling from lower potential to higher potential. That's why its value is positive E. Similarly, the second rule is, if we are traveling from positive of the battery to negative plate of the battery, again the direction is in the direction. So what is happening here? The value of EMF is E value. Now we can write this value as minus E. Why it is minus E? Because we are going from positive potential towards negative potential. This is minus. Is it clear? In case of battery, there are two rules. When we are traveling from minus to plus, this value of EMF is taken as positive E, and we are traveling from plus to minus, the value of EMF is taken as minus E. Is it clear? These two are the EMF rules. In the same way, we can also write the rules of resistance. So in case of resistance, assume that the value of resistance is R, and if current is I, what is the drop across this resistance? The drop across the resistance is always IR drop as per Ohm's law. But this value, whether it is positive or negative, how do we know? Suppose if the direction of travel is from this direction to that direction, along this there is a drop. From this point to this point, there is a drop in voltage. So that means direction of travel and actual current both are in the same direction. Then this value is taken as minus IR. Similarly, this is the third rule. The fourth rule is, suppose if the flow of current is in this direction and the direction of travel is in opposition to this one, then if both are opposite direction, that is actual current and direction of travel, in such a case, the drop is taken as positive drop. Is it clear? Rule 1, Rule 2, Rule 3, Rule 4. First you familiarize with these four rules, then you can easily apply the Kirchoff's voltage law to any closed mesh. Is it clear? Now, we will apply now. So after framing the rules, now we can apply the rules to the closed loop. So where from we start? We will start. So before applying the Kirchoff's voltage law, we already framed the rules. Now I am starting with node A. If you travel from node A toward this, first which one is encountering us? E1. So what is the direction? We are traveling from minus plate to plus plate. So according to our Kirchoff voltage law convention, what we have said, when we are traveling from minus to plus, this value is taken as positive E1. Now after that, what is there? There is a resistance. So in case of resistance, the direction of current is flowing from left to right, and your direction of travel also in the same direction. So that is according to rule number 3, if both are in the same direction, that is direction of actual current and direction of travel, both are in the same direction, then your drop is negative, minus I1 R1. Similarly, from this point to here, the direction of EMF is from plus to minus. According to rule 3, what we followed, so it is minus EMF, minus E2. Again, here in case of resistance, the potential drop is, the value of drop is product of current and resistance. But what is the sign, whether it is positive or negative? This value is in opposition to your actual direction of travel. So according to rule number 4, its value is I2 R2. Now come to here. So again here, when we are traveling from C to D, we encountered third battery. So third battery, how we are chosen? Minus to plus. So whenever we are traveling from minus to plus, this value is always voltage raised, plus E3. Again here, in case of resistance drop, the value of drop is I3 R3, but the direction of actual current and DOT both are in the same direction. Then its value is minus I3 R3. Now come back to D to A. When we are traveling from D to A, the battery value is direction from positive to negative. Therefore, its value is minus E4. Now, what about the drop? The drop is nothing but the product of current and resistance I4 R4. Now, what is the direction? The actual current is coming down and your direction of travel is in opposition to this one. Therefore, its value is plus I4 R4. Like that, if you start with node A, traveling towards B, C, D and again come back to A, your closed loop is over. So what is the statement? In any closed mesh, the algebraic sum of EMFs. Why it is algebraic sum? These are plus, minus, and the algebraic sum of IR drops, minus I1 R1 plus I2 R2 minus I3 R3 and plus I4 R4. When everything is completed in that closed mesh, the algebraic sum of EMFs and algebraic sum of IR drops, then that must be equal to your 0 value. Now, from this, we can simplify it in a simplified manner. You write all the EMFs on one side, then how we can write? Plus E1 minus E2 plus C3 and minus E4 equal to, take the drops to other side, minus becomes plus. Likewise, I1 R1 minus I2 R2 plus I3 R3 and minus I4 R4. Now on the left side, these are all EMFs and on the right side, these are all IR drops. So still there are plus and minus signs. That's why what we can write? We will write algebraic sum. So algebraic sum of EMFs equal to, similarly on the right side also these are plus and minus. So we can write algebraic sum of potential drops, or we can write IR drops. Is it clear? So finally what we can conclude? We can state the Kirchoff's voltage law like, in any closed mesh, the algebraic sum of EMFs plus the algebraic sum of IR drops is equal to 0. Or finally what we got? It can also be stated that the algebraic sum of EMFs equal to the algebraic sum of IR drops. Is it clear? Thank you.